Imagine moving a stone block that weighs 15 tons. No crane, no forklift, no machinery at all. Now imagine doing that 2 million times. Then stacking those blocks nearly 500 feet into the air with such precision that you can't slide a knife blade between them. And you have to finish the whole thing in about 20 years. Impossible, right? Yet it happened. Over 4,500 years ago, on the edge of the Egyptian desert, a civilization managed to do exactly that. They built something so massive, so accurate, and so enduring that even today, with all our technology, we still ask ourselves the same question: how? The Great Pyramid of Giza wasn't just big, it was the tallest structure on the planet for nearly 4,000 years. It contains roughly 2.3 million stone blocks. Some of those blocks were quarried 500 miles away and transported across a desert. The base of the pyramid is almost perfectly level. The sides align nearly perfectly with true north, south, east, and west. We're talking about accuracy within fractions of a degree. And here's what makes it even stranger. The people who built this didn't have iron tools. They didn't have wheels for heavy transport, no pulleys in the way we think of them, no written instruction manuals. Just copper chisels, wooden sledges, rope, and raw human effort. So when you stand in front of the Great Pyramid today, you're not just looking at old stones. You're looking at one of the greatest mysteries in human history. Because if this was possible 45 centuries ago, what did they know that we've forgotten? That's the question scientists, archaeologists, and engineers are still trying to answer. Some people say it's too perfect to be human work. They talk about aliens, lost civilizations, or ancient technologies we can't explain. But the truth? The truth is actually more impressive than any myth. Because the pyramids weren't built by magic, they were built by people. And we're about to show you exactly how they pulled it off. Let's talk numbers for a moment, because until you understand the scale, you can't fully grasp what the ancient Egyptians accomplished. The Great Pyramid of Khufu covers 13 acres of land. That's roughly the size of 7 city blocks. Its original height was 481 feet, about as tall as a modern 40-story building. For comparison, the Statue of Liberty would fit inside it with room to spare. Now here's where it gets serious. This pyramid contains approximately 2.3 million stone blocks. The average block weighs around 2.5 tons. That's the weight of a full-sized SUV. But many blocks weigh much more. Some of the granite blocks in the King's Chamber weigh up to 80 tons. 80 tons. That's heavier than a fully loaded semi-truck. And all of this was built in roughly 20 to 25 years. If you do the math, that means the workers had to quarry, transport, and set into place one block every 2 to 3 minutes, working around the clock, every single day, for 2 decades. Think about that for a second. Modern construction projects with steel, concrete, and heavy machinery take years just to plan. The Burj Khalifa, the tallest building in the world today, took 6 years to build with thousands of workers and cutting-edge technology. The pyramids were built with none of that. Engineers today look at the Great Pyramid and shake their heads. Not because they think it's impossible, but because they know how difficult it would be to replicate. The logistics alone are staggering, coordinating tens of thousands of workers, moving materials across vast distances, maintaining precision while working at that speed and scale. It's a project management nightmare even with modern tools. And yet, they did it. Without computers, without diesel engines, without steel cables or hydraulic lifts. They did it with planning, ingenuity, and sheer human willpower. That's what makes this so incredible. Not that it happened, but how it happened. And that's exactly what we're going to break down. Before you can build a pyramid, you need stone. Millions of tons of it. And that means quarrying on a scale that's hard to imagine. Most of the limestone used for the Great Pyramid came from local quarries right there on the Giza Plateau. These quarries are still visible today, just south of the pyramid. Workers carved massive blocks directly out of the bedrock. They didn't have explosives or diamond-tipped saws. What they had were copper chisels, wooden wedges, and stone hammers made from dolerite, one of the hardest rocks available. Here's how it worked. Workers would first mark out the size of the block they needed. Then they'd cut narrow trenches around it on all sides. They used copper tools to carve into the softer limestone, striking repeatedly until the trench was deep enough. Once the block was outlined, they'd insert wooden wedges into the bottom. They'd soak those wedges with water, and as the wood expanded, it would crack the block free from the bedrock below. It was slow, exhausting work, but it was effective, and they did it over and over again, extracting block after block, day after day. Now, the local limestone was good for the core of the pyramid, but it wasn't pretty. For the outer casing, the Egyptians wanted something smoother and whiter, so they went to Tura, a site across the Nile, about 10 miles away. Tura limestone was finer, almost marble-like. When the pyramid was finished, it was covered in this brilliant white stone that reflected sunlight like a beacon. You could see it for miles. But the most impressive material didn't come from nearby. It came from Aswan, over 500 miles to the south. That's where they quarried granite. The massive red granite blocks in the king's chamber, some weighing up to 80 tons, were cut from solid rock in Aswan and transported all the way to Giza. Think about that. 500 miles. No roads, no engines. Just the Nile River, wooden boats, and human determination. The evidence is still there. In Aswan, you can see unfinished obelisks still attached to the bedrock, abandoned mid-extraction. They show exactly how the Egyptians worked. Trenches, wedges, patience. This wasn't guesswork. This was engineering. Quarrying the stone was only the beginning. The real challenge was getting those massive blocks from the quarry to the construction site. And in some cases, that meant moving them hundreds of miles. Let's start with the granite from Aswan. These blocks weighed dozens of tons each, and they had to travel over 500 miles north to Giza. The Egyptians had one major advantage: the Nile River. The Nile wasn't just a water source, it was a highway. They built massive wooden barges specifically designed to carry these enormous stones. During the annual flood season, the river would rise, and the Egyptians used this to their advantage. Higher water levels meant they could navigate closer to the construction site and move heavier loads with less resistance. Archaeological evidence shows remnants of ancient harbors and canal systems near the pyramids. These weren't natural, they were engineered. The Egyptians dug canals from the Nile to the plateau, allowing boats to deliver stone as close as possible to the build site. It was logistics on a scale that rivals modern port operations. But once the stones arrived, they still had to be moved over land. No wheels, no carts strong enough to bear that weight. So what did they use? Sledges. Wooden sledges. And here's the brilliant part. They didn't drag them over dry sand. They wet the sand first. This isn't speculation. Scientists tested it. Wet sand reduces friction dramatically. When you pour water on sand, it binds the grains together and creates a firmer surface. A team of workers pulling a sledge over wet sand can move a block that would be nearly impossible to budge on dry ground. In fact, experiments showed that wetting the sand can reduce the pulling force needed by nearly half. There's even ancient artwork that depicts this. In the tomb of Jehuti-Hotep, there's a famous scene showing workers pulling a massive statue on a sledge. And right there in the image, a person is standing at the front, pouring water onto the sand. The Egyptians knew exactly what they were doing. Coordination was everything. These weren't random groups of people pulling stones. This was organized labor on a massive scale. Foremen directed teams. Work songs kept rhythm. Thousands of people moved in sync, pulling together. It was efficiency born out of necessity. And it worked. Block by block, ton by ton, the stones made their way to the pyramid. For a long time, people believed the pyramids were built by slaves. Hollywood movies showed thousands of people in chains, whipped and forced to work under brutal conditions. It's a powerful image, but it's completely wrong. The pyramids were not built by slaves. They were built by skilled workers. We know this because archaeologists have found their villages, their tools, and even their bones. And the evidence tells a very different story. In the 1990s, archaeologists discovered the tombs of pyramid workers near Giza. These weren't the tombs of slaves. They were proper burials, some with inscriptions honoring the workers for their contributions. Slaves don't get honored burials. These people were valued members of society. We've also found the remains of workers' villages. These settlements had bakeries, breweries, sleeping quarters, and even medical facilities. The workers were fed well. Analysis of animal bones shows they ate meat regularly, including beef and mutton. That's high-quality food. The state was investing in keeping these workers healthy and strong because the project depended on them. Medical evidence backs this up. Some of the skeletons show signs of healed fractures and injuries that were treated. Broken bones were set properly. Infections were cared for. This wasn't a disposable workforce. These were people the state needed and looked after. So who were they? Most were farmers. During the flood season, when the Nile overflowed and farming was impossible, thousands of workers would travel to Giza. It was a form of national service, a labor tax. You worked on the pyramid for a few months, then returned home. For many, it was also a religious duty. They believed they were helping to build a gateway to the afterlife for their god-king. That's powerful motivation. But it wasn't just unskilled labor. There were master stonemasons, architects, engineers, and surveyors. These were specialists who trained for years. The precision we see in the pyramids didn't happen by accident. It happened because skilled professionals designed and oversaw every step. This was a state-run operation, organized, systematic, and built on the backs of people who saw it as both duty and honor. Moving blocks horizontally was one thing, but lifting them? That's where the real mystery begins. The Great Pyramid rises nearly 500 feet into the air. How do you get multi-ton blocks up there without cranes or pulleys? The answer is ramps. Almost every expert agrees on that. But what kind of ramps? That's where the debate gets interesting, because we don't have definitive proof of exactly which method they used. What we have are theories, each with strengths and weaknesses. The simplest idea is a straight ramp. Imagine a long, gradual incline leading straight up one side of the pyramid. As the pyramid grows taller, the ramp grows longer to maintain a manageable slope. It's straightforward, and it would work. The problem? The higher the pyramid gets, the longer the ramp has to be. By the time you reach the top, you'd need a ramp over a mile long. That's an enormous amount of material, possibly more than the pyramid itself. And we haven't found evidence of a ramp that massive. Then there's the zigzag ramp theory. Instead of one long ramp, you build a series of switchbacks going up the side of the pyramid. It saves space and materials. Workers would haul blocks up one section, turn it a platform, then continue up the next. It's more compact than a straight ramp, but turning corners with multi-ton stones would be extremely difficult. The spiral ramp is another option. Picture a ramp that wraps around the outside of the pyramid as it rises, like a corkscrew. It's continuous, which makes it easier to keep materials flowing. But the problem is the corners. At the edges of the pyramid, the ramp would have to make sharp turns, and maneuvering heavy blocks around those turns would be a logistical nightmare. Then there's the internal ramp theory, and this one's fascinating. French architect Jean-Pierre Houdin proposed that the Egyptians used a ramp inside the pyramid itself. The outer layers were built with a traditional external ramp, but as the pyramid got taller, they constructed a spiraling tunnel inside the structure. Blocks were hauled up through this internal passage. It's clever because it solves the space problem and explains why we don't see massive external ramp remnants. Some imaging studies have even suggested there might be voids inside the pyramid that could support this idea, but it's still debated. The truth is, They might have used a combination, different methods for different stages of construction. And that's not a weakness in our understanding. It's a testament to their adaptability. The engineering required to move stones is impressive, but the precision? That's what leaves modern engineers speechless. Let's start with the base. The Great Pyramid covers 13 acres, and the base is almost perfectly level. We're talking about an error of less than an inch across the entire foundation. To achieve that today, we'd use laser levels and advanced surveying equipment. The Egyptians did it with water channels, wooden A-frames, and plumb bobs. They flooded trenches around the perimeter, marked the water level, and cut the bedrock to match. Simple in concept, extraordinary in execution. Then there's the alignment. The sides of the pyramid face almost exactly north, south, east, and west. The accuracy is within 1/15 of a degree. That's remarkable. How did they do it? Most likely, they used the stars. By tracking the circular path of stars around the celestial pole, they could determine true north with stunning precision. No compasses, just careful observation of the night sky. Now let's talk about the geometry. Each side of the pyramid was originally over 750 feet long. Despite that length, the difference between the longest and shortest side is less than 2 inches. 2 inches over 750 feet. That's not luck. That's planning and skill. And the stones themselves? They fit together so tightly that you can't slide a piece of paper between them in many places. No mortar, just stone on stone, cut and shaped with such accuracy that the joints are nearly invisible. Some of the casing stones that remain show a level of finish that rivals modern masonry. There's also a mathematical elegance to the design. The ratio of the pyramid's height to its base perimeter is very close to the ratio of a circle's radius to its circumference. In other words, it approximates pi. Whether this was intentional or coincidental is still debated, but either way, it shows a sophisticated understanding of geometry. Astronomy played a role too. The internal shafts in the king's and queen's chambers align with specific stars. Orion's belt and the star Thuban, which was the North Star in ancient Egypt. These weren't random. They had symbolic and religious significance, but they also demonstrate astronomical knowledge. The precision wasn't just for show, it was structural. A pyramid that isn't level, that isn't balanced, doesn't stand for 4,500 years. The Egyptians knew that. Every measurement, every angle, every cut mattered, and they got it right. Now that we understand the materials, the workforce, the transportation, and the precision, let's walk through how it all came together, step by step, from bare rock to finished monument. It starts with site preparation. Before a single stone was laid, the ground had to be ready. Workers cleared the area, removing sand and loose rock down to the solid bedrock. This wasn't optional. The pyramid's massive weight required a stable foundation, and bedrock was the only option. Once exposed, they leveled it using the water channel method we talked about earlier. Trenches were cut, flooded, and the bedrock was carved down to create a perfectly flat surface. Next came the foundation blocks. These were the largest and heaviest stones in the entire structure. Some weighed over 15 tons. They were placed directly on the leveled bedrock, forming the outer perimeter and the base layer. Precision was critical here. If the foundation wasn't square, if the corners weren't exactly 90 degrees, the entire pyramid would be off. So they measured, adjusted, and checked repeatedly. With the foundation set, the core construction began. Most of the pyramid's interior is made of roughly cut local limestone. These core blocks didn't need to be perfect. They just needed to be strong and stackable. Workers laid them in horizontal courses, row after row, building upward. As each level was completed, ramps were adjusted or extended to allow the next level to be built. While the core rose, the outer casing stones were prepared. These were the fine Tura limestone blocks that gave the pyramid its smooth, gleaming surface. Each casing stone was cut with extreme precision. The outer face was polished, the edges beveled to fit perfectly with the blocks above, below, and beside it. They were placed from the bottom up, working in tandem with the core construction. Inside, the internal chambers and passages were being built simultaneously. The king's chamber, the queen's chamber, the grand gallery, all of these required careful planning. Massive granite beams were hauled up and positioned as ceilings. Passageways were aligned with astronomical precision. Finally, the capstone, the pyramidion. This was the final piece, placed at the very top. In Khufu's pyramid, it's believed to have been covered in gold or electrum, shining like a beacon. Its placement marked the completion of one of humanity's greatest achievements. Every stage required coordination, skill, and relentless effort, and it worked. With something as impressive as the pyramids, it's no surprise that myths and wild theories have emerged. Some of them are entertaining, others are persistent, but none of them hold up to evidence. Let's start with the big one: aliens. The idea that extraterrestrials built the pyramids has been around for decades, fueled by books, documentaries, and internet speculation. The argument usually goes like this: the pyramids are too advanced, too precise, too massive for ancient humans to have built. Therefore, it must have been aliens. But here's the problem. We have evidence of how the pyramids were built. We've found the quarries. We've found the tools. We've found the worker villages, the food supplies, and the tombs of the people who did the work. We have ancient records, papyrus documents that describe the logistics of stone transport. We even have unfinished pyramids that show construction techniques in progress. There's a clear, human trail from start to finish. The idea that ancient people couldn't have done this isn't based on evidence. It's based on underestimating human ingenuity. The Egyptians weren't primitive. They had mathematics, astronomy, engineering knowledge, and organizational skills that rivaled any civilization. Suggesting aliens is actually insulting to the people who spent their lives making this happen. Then there's the lost technology myth. The idea that the Egyptians had advanced machines or tools that we've somehow forgotten. Again, we have the tools: copper chisels, stone hammers, wooden sledges, ropes. They're in museums. They've been tested. They work. There's no mystery technology, just smart use of what they had. And the slave myth, which we've already covered, but it bears repeating: no slaves, skilled workers, paid laborers, people who were fed, housed, and cared for. The evidence is overwhelming. So why do these myths persist? Partly because the pyramids are so impressive that it's hard to believe humans did it without help. Partly because mystery sells. Documentaries about aliens get more views than documentaries about ramps and sledges. And partly because there's a tendency to romanticize the past, to think that ancient people either had secret knowledge or needed outside help. But the truth is more empowering. The pyramids prove that humans, working together with intelligence and determination, can achieve the seemingly impossible. We don't need aliens. We don't need lost technology. We just need to respect what our ancestors were capable of. The pyramids are a human achievement, and that makes them even more incredible. The pyramids were built over 4,000 years ago, so why do they still matter? Why do engineers, architects, and millions of tourists still look at them with wonder? Because they represent something timeless. They show us what's possible when human ambition meets careful planning and skilled execution. In a world obsessed with the latest technology, the pyramids remind us that intelligence and determination can achieve monumental things with surprisingly simple tools. Modern architects study the pyramids not just as historical relics, but as lessons in durability and design. These structures have survived earthquakes, sandstorms, erosion, and the passage of millennia. Most buildings today won't last a century. The pyramids have lasted 45 centuries and show no signs of falling. That kind of longevity doesn't happen by accident. It's the result of understanding materials, geometry, and environmental forces at a deep level. There's also a lesson in sustainability. The pyramids were built using local materials. The limestone came from nearby quarries. The labor force was seasonal, taking advantage of agricultural downtime. There was no waste in the design. Every block had a purpose. Every measurement mattered. It was efficient not because they were trying to be green, but because efficiency was necessary. And then there's the sheer ambition. Pharaoh Khufu didn't need to build something this massive. He could have built a smaller tomb, but he chose to create something that would stand forever. Something that would announce to the world and to history that Egypt was powerful, organized, and capable of greatness. That ambition drove tens of thousands of people to work toward a single, unified goal. We don't build like this anymore, not because we can't, but because we don't need to. Our priorities have changed. But every so often, someone asks the question, could we build a pyramid today using only ancient methods? And the answer is probably yes, but it would be incredibly difficult. Coordinating the labor, sourcing the materials, maintaining precision over decades, it would require a level of commitment and focus that's rare in the modern world. The pyramids matter because they prove that human beings, when organized and motivated, can accomplish things that seem impossible. They're a reminder that our ancestors weren't less intelligent than we are. They just had different challenges and different tools. And they rose to meet those challenges in ways that still leave us in awe. So here we are, at the end of our journey through one of history's most enduring mysteries. And what have we learned? The pyramids weren't built by aliens. They weren't built by slaves. They weren't the result of lost technology or supernatural powers. They were built by people, ordinary people with extraordinary skills, working under brilliant leadership, driven by faith, duty, and national pride. They had copper chisels, not power tools. They had wooden sledges, not trucks. They had ropes and ramps, not cranes and pulleys. And yet, they moved 2.3 million blocks of stone, some weighing as much as 80 tons, and assembled them into a structure so precise that we're still studying it today. They understood mathematics and astronomy. They mastered logistics on a scale that would challenge modern project managers. They built with an eye toward eternity, and they succeeded. 45 centuries later, the pyramids still stand, barely weathered, perfectly balanced, a testament to what humans can achieve when we combine intelligence, planning, and determination. This wasn't a miracle. It was engineering. It wasn't magic. It was hard work, repeated day after day, year after year, by people who believed in something bigger than themselves. It was the product of a society that valued knowledge, respected skill, and organized itself around a common goal. And that's the real lesson of the pyramids. Not that ancient people had secrets we've lost, but that they had something we sometimes forget: the willingness to dream impossibly big and then do the work to make it real. Could we build the Great Pyramid today using the same methods? Maybe. But it would require tens of thousands of people working in unison for decades. It would require precision without computers, coordination without radios, and commitment without shortcuts. It would require us to think and work the way the ancient Egyptians did, and that's not a small ask. The pyramids stand as proof that humanity has always been capable of greatness. We just have to choose it. We have to plan for it, and we have to see it through. So the next time you see an image of the pyramids, don't think of mystery, think of mastery. Don't think of the impossible. Think of what becomes possible when people refuse to accept limits. The pyramids are humanity's greatest construction feat, not because of what they are, but because of what they represent. And that will never get old.